In this video, we are going to go through the process of calculating variability the long way. And we're going to do it on this data set that I have up here that was in the previous videos. So we're looking at the relationship between noise and memory. And we have up here a group that got some noise, a group that didn't get some noise, and these are the number of items they remembered. So this data is just summarized from the previous video. So we have our sum. Remember, our sums are capital letters. So capital A1, N A1, and Y bar A1. Same thing over here for group 2, A2, N2, and Y bar A2. We have little a, which is the number of groups, little n, which is the number of subjects per group, capital T, which is the grand sum, or the sum of all the scores, which is 35, and Y bar T, which is the grand mean, or the mean of all the scores. So we are going to calculate variability the long way. This video, I'm just warning you in advance, is like poking yourself in the eye with a pencil. It is grueling and tedious, but we're going to do it this way just so that you can really see where these calculations come from. And then once we do it this one way, there's going to be a homework associated with it. Once we do it the long way one time, we're going to move on to the shortcut formulas. Okay, so the way that we're going to do this is you are going to need 9 columns. So if you write big, I would recommend turning your page to the side. So turning it lengthwise so that you have a little more room. But we're going to need 9 columns to do this problem. And we're going to start in the 3rd column. So leave a little space here, a little space here, and we're going to start in this 3rd column. And I'm going to label this 3rd column Y. All right, so if at any point during this video you need to pause just so that you can get yourself caught up, please feel free to do that. We're going to start in this 3rd column and we're going to label it Y. All right, and if you remember, I'm going to just put a little line here. If you remember from a couple weeks ago, Y refers to what? Y refers to our scores. So here are our scores. Our scores are these data points in here under the noise and the no noise columns. So what we're going to do here is we're going to write our Y's in this column, and we're going to include them all. So we're going to do them a group at a time. I'm going to start with my noise group, so 2, 0, 0, 1, 2, and right underneath that I'm going to write my no noise numbers. So 5, 6, 8, 7, and 4. Now, as we move through this problem, we want to make sure, so even though we have all of our scores in this column, and if we had a 3rd group, we would put them below that, even though we have all our scores in a single column, we want to really make sure that we're keeping track of one group versus another. So I'm going to go ahead and take a pen and draw a line to divide the 1st group from the 2nd group for the entirety of the problem. All right. So now we're going to move one column to the left, and we're going to label this column Y bar A. So if you're starting to keep track of these things, Y bar A is right here. We have 2 of them. We have Y bar A1 and Y bar A2. And in fact, what we're going to put in this column are the Y bar A's for each group, so the means of the group. So this first group here, the Y bar A is 1. So I'm just going to write 1, 1, 1, 1, 1. And for the 2nd group, the Y bar A is 6. So I'm just going to write 6, 6, 6, 6, and 6. So I haven't done anything magical here. All I've done is I've transferred the means of those groups into this column. And then our very first column, we're going to label Y bar T. And again, if you're starting to keep track of this notation, Y bar T is right here. It's the grand mean. And because the grand mean refers to all the scores, it's across the whole problem, I'm going to write 3.5 all the way down this column. 3.5. 3.5, 3.5. Okay, So we haven't really done anything magical. We've actually done no math. At this point, all we've done is we've taken data from here and we've aligned it in these first 3 columns of this data set. All right, so we've got our y bar t in the first column, we've got our y bar a's, and we have 2 of them in the second column, and the third column is our y's. All right, so now we're going to move on to calculate our variance and our variability. So we're going to start with the variability that we've done in the past. We're going to look at the within group or the within subjects variability. So the first thing that we're going to look at is how these scores compare to one another and how these scores compare to one another. Okay, this is our within group or our within subjects variability. And in order to do that, we are going to do some calculations. And these calculations hopefully will look kind of similar to what we did when we did variance calculations on the last exam. The first thing that we're going to do, and this is going to be column 4, is we are going to take y minus y bar a. All right, y minus y bar a. What we're doing here is we're taking each score and we're going to subtract the mean of that group. All right, so we're going to take each score and subtract the mean of the group. All right, so for this first row, the score is 2, y bar a is 1, so 2 minus 1 is 1. Moving down to the next one, we have 0 minus 1 is negative 1. 0 minus 1 is negative 1, 1 minus 1 is 0, and 2 minus 1 is 1. Okay, moving down to this next group, we're doing the same exact thing that we did at the top, we just have a different mean. All right, so 5 minus 6 is negative 1, 6 minus 6 is 0, 8 minus 6 is 2, 7 minus 6 is 1, and 4 minus 6 is negative 2. All right, and what's really important here, and this is going to be the case as we move through the ANOVA, at each step in this process there are ways where we can check our work. So this is the first place where we can check our work. The sum of this column, when we add up all 10 of these scores, should be 0. Okay, these are called deviations. This is how each score deviates from its group mean. And the sum of this column should be 0. So you want to make sure that you go through and add those up. Make sure that it equals 0. I already checked this, so I know that it does. All right, now if you remember back from when we did variance on the last exam, the next thing we did once we got the deviations, hopefully you remember, we squared them. All right, so what we're going to do now is we're going to square these deviations. All right, so 1 squared is 1, negative 1 squared, remember, is positive 1. I'm just going to, for the sake of time, I'm just going to fill in the answers here. So negative 1 squared is 1, 0 squared is 0, 1 squared is 1. Negative 1 squared is 1, 0 squared is 0, 2 squared is 4, 1 squared is 1, and negative 2 squared is 4. And when we add up this column, the sum of this column is 14. Now, if you remember when we did this for the last exam, the sum of the squared deviations had a special name. We called it a sum of squares, or an SS. Now the thing is, we're doing the one-way ANOVA now, so we're going to have a couple different sums of squares. So we need to have a way of referring to this sum of squares in comparison to different sums of squares. So what we've done here is our within subjects variance. All right, so we got our within subjects deviation and we got our squared deviations. The within subjects, moving forward, we are going to be referring to, at least in the one-way ANOVA, as S over A. So what we've calculated here is the sum of squares, S over A. which means the sum of squares for subjects within group A. All right, so don't get too caught up in the notation. Don't worry, what is this S over A business? We're going to be practicing. Just, this is the first time I'm introducing it. All right, so what we have here is our sum of squares, S over A. All right, so in the interest of time, I'm going to pause this video now. I'm going to rewrite this just so it's a little bit easier for you to read it. But we're going to follow in the next video. We're going to carry on with our between subject sum of squares, and then finally we're going to do our total sum of squares.